So we were discussing design concepts, and we would be having few diagrams. Few diagrams you probably have already made in requirement analysis and initial understanding of requirements like class design during UML. And we have few more, and these are called design elements. So the first one is about data. The data design, or we call it data architecturing, is about how data would be modeled, what kind of abstraction we would be having, and how the user would be looking at data. So the data diagram or the data storage is a key factor. The second one is architectural design, which is actually the main view of the system, how it would be looking. This is like a floor plan of the house where you would be having the details about how big the room would be, the shape, size, etc., and at what distance it would be from each other. So it would be having the basic understanding of all the components in the system. The third one, we have interface design. Interface, as we discussed, are of three types. One, the internal interface, which is from component to component, how they are talking to each other. Other one, external, that how one device or one component is talking to other component, which is outside the design or outside the system. And third, and very important, the user interface, how the look of the system is given to the user or how user will handle it. The interfaces are very important in design and very critical. What you have done inside the box, inside the module, it impacts less to the outsider or to the user if the functionality in the connection, if the interface, the way it is connecting to other is running smooth and giving the services smoothly. So if you see a design of interfaces, so this is the diagram I was talking about. We have three classes here, and this is a representation of interface implementation where the control panel class has one interface as keyboard, and also you can use the Java type of implementation for stereotype. We also call that in object-oriented programming, and this is also keypad. So two type of interface are given with the same name as keypad, and this can be implemented using the Java interfaces available in Java 8 and further. And we can implement this, we can show this with the realization in UML, while keypad would be having as the behavior of control panel class. One more design element we are having, that is component level design, and this is also called the detailed design. So what component you have shown in architectural design, this is the detailed version of that. Here we can add extra details. So this is one example, figure 8.6 of component level design. And finally we have deployment level design, that how system would be deployed and different components and connectors would be there. And 8.7 in chapter 8 is given as deployment diagram of the system. So we have different components, how they are connected and how they are showing their behavior, that all would be shown in the deployment diagram. Also, I would be talking about patterns, and I think it would be better to show you what are the patterns and how they look like. So on this slide There are two patterns. One is the batch sequential pattern, which is shown here at the bottom, and this is quite traditional and not in use very much. We have pipe and filters, where we show pipe as connectors and filters for components for operations, and the pipe and filter has been in use in many systems. How we will implement those using the components and the interfaces which you would be designing, that you have to apply accordingly. Another quite popular pattern is data-centered architecture, or we also call it repository pattern, where the data architecture is at one place and all the components, all the users would be talking to centralized data. There are pros and cons of this system. The failure at one point can damage the whole system, so it is better to have the redundancy in the services which somebody is providing, let's say data store. Although the easiness in accessing and service at few places make it more convenient. So implementing this pattern has been in use for a long time. We would be talking about patterns in a separate series of lectures later. I'm just showing you today how the pattern look like and why they are quite important. Another one is layered architecture. If you have studied computer network, that is a 5-layer or 7-layer architecture. If you have seen operating systems design, you have the user level, kernel level, and other processes. That is also a layered architecture. So if you see the systems which you have studied, maybe from electronics, maybe from computer science books, and you see their architecture, you will find either they are repository system, layered system, or pipe and filter system. So the existing system design will help you in understanding these architecture. And one pattern I have already showed you, that is MVC, Model View Controller, in last class. That is a very, very popular pattern in software industry. Now, before going further, I would like to discuss a case study of a design which is a safe house system. This is the example has been discussed in the textbook Pressman in many chapters and has shown the diagrams and the detail at different places. So I would suggest to all of you to go through this document. I will upload it. Read this in parallel with the textbook reading and let me know what is your view on this design. This is taking a different version of UML called Argo UML that is free and available, and it has given the details of the safe house and its different diagrams. Let's say use case diagram, and then you have deployment diagram and the class diagram for this, as well as different state and activity diagrams with the behavior diagrams for different interfaces. So this would be a good case study to understand the design of a complex system which involved multiplayer and multi-component structure and how to handle the design of such kind of system. Now we will continue about the design concepts which we were discussing in last week. So now I have showed you what are patterns, and I have also showed you few architectural diagrams, and you also have seen the interface, different type of interfaces, and the behavior diagram, or how the interface will react in different scenarios.